Going to be the third video for the Unit 1A assessment review. So far we've done the number system, right? We looked at rationals, irrationals. We looked at the whole numbers and the natural numbers. Then we went to the converting decimals, repeating decimals to fractions. Okay. So now what we're gonna do is, so we can put a little red check mark on the converting decimals to fractions. So now what we're gonna do is we're going to look at approximating square roots and approximating numbers in general. Okay. So let's get started. All right. So here we have approximating square roots and approximating in general. All right. So don't forget the very first thing we did we listed the square roots. Okay. So the first thing we did was we looked at 1 times 1 equals 1, which meant the square root of 1 equals 1. Then we looked at 2 times 2 equals 4, which meant that the square root of 4 is 2. Then we did 3 times 3 is 9, which means the square root of 9 is 3. 4 times 4 is 16, which means the square root of 16 is 4. 5 times 5 is 25, which means the square root of 25 is 5. And notice what's going on here. It's the same number times itself gives us a number. So for example, 3 times 3 gives us 9. That means the square root of 9 is 3. The square root of 9 is not 3 times 3. Okay, the square root of 9 is one number, just 3. Okay, and we did the same thing up to the 15s. Okay, so 15 times 15 is 225, which means that the square root of 225 is 15. Okay, so let's look at an example here. This question's asking us between what two numbers is the square root of 55. So what are we going to do? Well, the first thing that I like to do is I like to just write down the number right in here. Okay, so this number is just 55. Okay, so the next thing that I do is I go and find this perfect square, right? All these are perfect squares. 1, 4, 9, 16, 25, 36, 81. These are the perfect squares. I go and find the next perfect square, the one largest than the one that we're looking for. So in this case, we're trying to approximate the square root of 55. So we go to the next highest square root, perfect square, which in this case is going to be 64. Okay, so 55 is less than 64. We put that little less than sign there. Okay, and then we do the same thing, except instead of finding the one that's larger than 55, the next one that's bigger than 55, we look to see which one's smaller than 55. Okay, in this case it's 49, right? Because 55 occurs somewhere in here, somewhere between 49 and 64. So once we do that, it's pretty nice, because what we could do after that is take the square root of everything in here, because square root preserves inequalities, means these signs don't flip and they don't change, they stay the same. Okay, so square root preserves inequalities, so we can square root all of these numbers. Okay, so that means that the square root of 55 is less than the square root of 64, and the square root of 55 is greater than the square root of 49. Well, let's look at our little cheat sheet here that we have, okay? And I strongly recommend you memorize these, okay? These are really useful to know, especially for the test, okay? So the square root of 49, if we look at our little sheet, the square root of 49 is 7. So we can, instead of square root of 49, we can change it to a 7. Less than. The square root of 55 we don't know from our list, so we'll just leave it alone. And then we'll put our less than. The square root of 64 we do know, because it's a perfect square, okay, which is why we chose it, and it's 8. So there we go. We know that the square root of 55 is between 7 and 8. So if we were to plot that on a number line, maybe we put 0 here, maybe 1 here, okay, and let's put 7 here, 8, 9, okay? So the square root of 55 is somewhere between 7 and 8. Maybe we don't know exactly where, but we can give a rough estimate. So maybe just right here. Okay, so that's going to be the square root of 55. All right, let's do the same thing with this next example. instead of saying between what two numbers is the square root of 55, let's use some different vocabulary. Let's say approximate square root of 7. Okay, so it means the same thing. It means try to see what two numbers is in between. Okay, so let's look at square root of 7. Okay, so the first thing I like to do is I like to put the 7 down. Okay, then I like to put this less than sign. Okay, and this greater than sign. All right, and we know that these two numbers that we're going to put on the left and right of the 7 are going to be the perfect squares that we're going to choose from. Okay, so the first one we're going to look at is the next one, the perfect square that's bigger, a little bit bigger than 7. Well, that means we're somewhere in this group, right? And if we look at these numbers, we have 1, 4, 9, 16. Okay, so that means the next one larger than 7 is going to be the 9. So that means we can put a 9 here. Okay, and the perfect square that's right below 7, we can see here is going to be 4. Okay, so we can put a 4 here. Okay, and what did we do before? We said that the square root preserves inequalities. So we took the square root of every number in here. Okay, and after that we can simplify it. Okay, so the square root of 4 we have here is 2, right? Because 2 times 2 is 4. So the square root of 4 is 2. Less than the square root of 7 we don't know. Let's just leave it alone. Right? We're trying to approximate it. Okay. Less than the square root of 9 we do know. The square root of 9 is 3. Because 3 times 3 is 9. The square root of 9 is 3. And there we go. We have that the square root of 7 is in between 2 and 3. So we can do the same thing as before with the number line. Okay. And square root of 7 is somewhere between 2 and 3. And maybe we'll just put it right here. So there we go. We have square root of 7. What could we say about this first one? Maybe if we could write a couple of sentences describing the actual place, the position of square root of 55, right? So maybe we could say the square root of 55 is to the left of 8. Right? We could say that the square root of 55 is to the left of 8, right? Because the square root of 55 is right here. It's in between 7 and 8. So it's to the left of 8. And then maybe we could also say, and to the right of 7. Okay, so the square root of 55 is to the left of 8, but to the right of 7. Okay, so that's why it's right in between here. We can say another sentence for the square root of 7, right? We could say the square root of 7, maybe we'll start with to the right, is to the right of 2, right? Because it was between 2 and 3, right? From the inequality that we found, is to the right of 2 and to the left of 3. Okay, so those are just some little sentences that we could say about each one of these. All right, so let's go to this next slide. And now it says approximate square root of 76 and plot on a number line. Okay.